Okay. Um, so the assignments from 1.2 and 1.3 due this evening. Um, I'll try to have them graded tonight. I think I might be able to do that. And WebAssign for these sections are due as well. Um, and exam 1 tomorrow, covering sections P2 to P8 and 1.1 to 1.4. So make sure for tomorrow that you have a working webcam. Please don't make me start like saying, Joe, turn on your webcam. Mark, turn on your webcam. Make sure your webcam is working. There's a couple different things you need to do for that. So if you see down here, this is where you turn on your camera right here with this button. Okay. Well, I can't do it while I'm sharing my screen, but you turn it on there. All right. If it doesn't work here, then what you need to do is go up to your browser bar here. I mean, if you're using Chrome, if you're using some other browser, it probably has some similar icon up here, and you have to give your browser permission to access your web camera or something like that. Okay, so right, access to the microphone, access to the camera. It's all right there, but you have to push this first before you go into that. All right. And it's probably other places in the settings in Chrome as well. All right. So you have to give your browser permission. Please do that before tomorrow. Okay. So let's talk about that. Make sure you have a working webcam. Please check your settings before class. Okay, so how it's going to go, the exam. So one, everyone turns on their. So we'll meet at the usual time. Two, everyone turns on their webcams. Three, I'll email the exam to you. Four, complete the exam with pencil and paper. Five, scan your exam, upload to Dropbox. And upload to Dropbox. So I'll have a folder set up on Dropbox for for the exam, and then all uploads will need to be complete. By class, so it's 9:50 to 10:55. And I need to, you need to stay online while uploading. And it's everyone's business to make sure that you scanned all your work. okay, to make sure everything is scanned and then it's uploaded. Okay, that's your responsibility to do that. I cannot accept anything late at all. Okay. Oh, I forgot to upload this. I forgot to upload that. I forgot to scan this page. Forgot to scan that page. I cannot do anything for you. Okay, there cannot be anything uploaded late. Okay, it's an exam. We have to complete the exam during class time, and you have to make sure that you scanned everything you need to scan and hand in everything you need to hand in. Okay. All right. So, and you can have a calculator is allowed during the exam, but no internet enabled devices. Right. No phones, browsers, etc. I mean, except for the fact that you're going to be using your browser to do Collaborate Ultra, but I mean, you know, um, no usage of the computer other than that, no usage of the smartphone other than to scan your exam at the end. Okay. Is there any questions about that, guys? Any questions about any of that? All right. So today we're just going to be going over discussion problems from sections 1.3 and 1.4. Okay, so on the syllabus for section 1.3, 9 through 51, every third problem. So how about which ones did I ask you to hand in? Make sure I don't do those. 48, 52. 52, 48. All right. So how about number 24? So section 1.3, 24. So find the equation of the line with slope equal to 2/5 and y-intercept equal to 4. All right. Well, this one is pretty straightforward, right? With the slope intercept form of the line, it's y equals mx plus b, where m is the slope and b is the y-intercept. So in this case, it's just 2/5 x plus 4. All right, so it just gives you the slope and the y-intercept, and so you get the equation, and that's it. 27. So find the equation of the line with slope 2/5 and through the point 1/7. Or 2/3, sorry. right? So you have slope 2/3, and then you're running through the point 1, 7. So this one here, right, you have y-intercept 4, and then the x-intercept is going to be what? So 4 times 5/2, 10. Let's make that lower, I guess. 4 and 10. So, negative 10.
You're using the formula from the first problem.
Yeah, I know. I'm just drawing the line for you. So this line looks like that. Okay, this line, it goes through the point 1, 7. So I'm not going to draw the x and y axis for this one here. But, you know, it's not asking you to graph the line on these problems, but I'm going to do it anyway. I certainly want to ask you to graph a line on the exam, so you might as well do it as long as we're at it. All right, so find the equation of the line with this slope and that point, going through that point. Well, in this case, instead of the slope-intercept form, you can use the point-slope form. All right, the point-slope form of the line is y minus b is equal to mx minus a, where in this point, in this example, AB is the point 1, 7. That's the point that you're moving through. So two things that you need for the line. You need, right, the slope, and you need some point. Preferably, if you have the y-intercept, it makes life a little easier because, you know, you can just write the slope-intercept form of the equation. So here, it's y minus b is the y-coordinate, is equal to m 2/3 x minus a, which is 1. All right. So that's an acceptable answer. That's fine. That's an acceptable answer. Sometimes, you know, folks like the slope-intercept form better because it's unique. Right? This equation for the line point-slope form is not unique because you can use any point on the line. Right? So the point 1, 7 or any other point on the line, you can stick it in for AB and it works. You know, but the slope-intercept form is unique, so this one isn't. So if you want, you can put it in slope-intercept form. You do that by adding 7 to each side to push this constant over here. So y is 2/3 x minus 1 plus 7. Distribute the slope, or not 7, y. Distribute the slope, 2/3 x minus 2/3 plus 7. Add those constants. So this is 21/3 minus 2/3 is 19/3. All right, so there's your slope-intercept formula. Either answer is acceptable. Okay. 30. So we'll find the equation, an equation of the line through. So in this case, you got 2 points, -1, -2, and 4, 3. All right, so you've got these 2 points on the line, -1, -2, and 4, 3. So, you know, again, you need 2 ingredients to get the equation of a line, slope and a point on the line. I got 2 points on the line, but I don't have the slope. But 2 points on the line is enough to define the line because it'll give you the slope. Right? The slope is equal to the rise over the run, right? Meaning, right, this is the run, this is the rise, right? Which it means the change in y over the change in x. So it's change in y is 3 minus 2 over 4 minus 1. When you say change, it's subtraction, right? So y coordinate 3 minus y coordinate negative 2, y coordinate 4 minus y coordinate negative 1 turns out to be 5 fifths, which is just 1, so slope 1. All right, so we have slope 1, and we have 2 points on the line, 4, 3. So the point slope form for the line the point slope form for the line is that. So in this case, and you can pick either point. Y minus 4 is equal to the slope, which is 1 times x backwards. Y minus 3, the y coordinate is 3, equals x minus 4. So that's an acceptable answer, or you can add 3 to both sides and just get y equals x minus 1. Okay, so slope 1, y-intercept, negative 1. $30, $33, x-intercept 1, y-intercept negative 3. So again, find the equation. So y-intercept 1, no, negative 3, x-intercept 1. So this is the x-axis, and there's 1. And then the y-intercept is 1, 2, 3, negative 3. So negative 3 on the y-axis, 1 on the x-axis. So you can get an accurate graph of this line. Like that. Well, I've got the y-intercept. All I need is the slope. Right? So to calculate the slope, right, I need to do that slope calculation. Now, what are the coordinates of this point? The x-coordinate is 1. What's the y-coordinate? Here?
0.
0, right? So this is actually the point 1, comma 0. This is the point 0, comma minus 3. So to do that slope calculation, right, change in y over change in x, it's 0 minus 3 over 1 minus 0, change in y over change in x. So that's 3. So slope of 3. So you can do the slope-intercept form. Y is equal to 3x minus 3. Right. Slope-intercept form because you're given the intercept. Uh, 36, don't worry about that for now. Or don't worry about 36 for now. 39, line through the point 1, 2 and parallel to this line. Parallel to the line, y equals 3x minus 5. Well, parallel means they have what? When they have what?
The same slope.
The same slope. Right? When they have the same slope. Right? This line has slope equal to what? Well, that's the point slope form. When it's solved for y, that's the point slope form. Y is equal to mx plus b. So what's the slope in this case?
3.
3. Right, so the equation of the line here using point slope is y minus b is equal to mx minus a. So you have y minus 2 is equal to 3 x minus 1. So this is the line with the same slope, 3, but passing through the point 1, 2. So that's an acceptable answer, or if you want to put it in point slope form, then it's that. All right, so y equals 3x minus 1. That's the line we were looking for here. Minus 3 plus 2, yeah. This is the line that we were looking for, and you notice it's the same as that, right, except for the y-intercept. Y equals 3x minus 5, y equals 3x minus 1. So same slope, different y-intercept.
In that formula, if A and B represent points on the line, then what are x and y?
Well, the x and y is any other point on the line. So every point on the line, x, y, satisfies that equation. So, in this example here, so y-intercept is negative 1. X-intercept is going to be 1/3. And one of the points that the line passes through is, what was the point they gave you? 1, 2. So here's 1, so that's 1/3. And then that's 1, and then this is 2. All right, that's the point 1, 2. Now, for any other xy, so if this is some x, and you go straight up or straight down to the line, and then you touch the line here, and then here is the point on the y-axis that you get by traveling horizontally. Right, so at x, you travel vertically up or down till you hit the line, and then you stop, and then you travel horizontally left or right till you hit the y-axis. So this point is x, y. And every point x, y satisfies this equation. Y equals 3x minus 1. Like this xy down here, or anywhere off the line, this does not satisfy. Y equal to 3x minus 1. In other words, if I took this x value, whatever it is, like 2/3, and I plugged it into here, then it'll give me that y value, right, which is going to be 1. Right? Like this was 2/3, and that's 1. If you took this point here and you stuck the x into the 3x minus 1, it would not equal whatever the y coordinate is. Okay?
Yeah.
Makes sense? Yeah. Uh, 42. Let's leave that out for now. 42, 45. No, let's not do that. 48, that was one of the ones to hand in. So let's do something like 48. So 47. So 47, which is like number 48. So find the equation of the line through -1, -2. And perpendicular to the line 2x plus 5y plus 8. So now they've really got that equation of the line jumbled up. Okay, it is neither in slope-intercept form nor in point-slope form. Okay, but you can always put it in slope-intercept form. Okay, and you will need to do that because, right, two lines are perpendicular. So remember, two lines are perpendicular when their slopes m and n satisfy, well, when one has slope m are m and -1 over m, i.e. negative reciprocals. Okay, so two lines are perpendicular when their slopes are negative reciprocals. So like 2 and -1/2, or -2 and +1/2, or 2/3 and -3/2. So whatever the slope is, you make it a fraction, you flip it upside down, you negate. If it was negative, it becomes positive. If it was positive, it becomes negative. Okay, so we would be in business, you know, we could just apply the point slope form, because we got a point. We could apply the point slope form formula for the line if we knew the slope. But we don't know the slope because we don't see the slope of that line. You can't see it until you put it into the slope-intercept form. Okay, so 2x plus 5y plus 8 equals 0. Let's put this in slope-intercept form. So that we can see what the slope is. Right, so you need to solve for y. So leave y on this side and move everything else over to the other side. Alright, so we add, or we subtract 2x and 8 from one side and add them to subtract them from the other side as well. Alright, and so we subtract 2x and subtract 8 from both sides. Alright, so we're left with 5y on the left and minus 2x minus 8 on the right. Divide by 5 on the left, divide by 5 on the right, and we get y is equal to minus 2/5 x minus 8/5. Okay, so the slope is minus 2/5. So the perpendicular slope is what? What is the perpendicular slope?
5/2.
Yeah, 5/2. So perpendicular slope is equal to 5/2. So the line we're looking for, going back to the point slope form, where AB was equal to, what was it? -1, -2. All right, so y minus b, but b is -2, so it's y plus 2 is equal to the slope 5/2 x minus a. A is negative, so it becomes x plus 1. So there it is. And you can put it into point slope form if you want. This answer is perfectly fine. Point slope form, if you want, it looks like this. So 5/2 x plus 5/2 minus 2. So y is equal to 5/2 x, and then 2 is 4/2. So 5/2 minus 4/2 is 1/2. So that is the line that we're looking for here. This answer or that answer is acceptable. All right, so the homework problem. The homework problem 48 is just like that. All right, it's the same question. 48 says, find the equation of the line through the point 1,7 and perpendicular to this line 4x minus 8y equals 1. So you do the same song and dance here. All right, they give you a point for the line to go through and say it's perpendicular to this other line, but the equation for that other line is all jumbled up. Okay, so basically first you have to take the equation for that other line, okay, and put it into slope-intercept form. Why? So you see the slope. So this one has slope -2/5. What do they want? Parallel or perpendicular? They said perpendicular line. Perpendicular line, if this one's got slope -2/5, the perpendicular line has slope +5/2, the negative reciprocal. So that's the slope of the perpendicular line. That's the point it goes through. Put it in the point slope form. Hold on. Right? Let's do 51. So in 51, which is like 52, which is the one to hand in, sketch the line with slope 3/2 that passes through the point -2, 1. With slope 3/2 passes through the point -2, 1. Right? So first thing you need to do is get the equation of the line. First find the equation of the line. So y minus b is equal to mx minus a. Okay, so you have y minus 1 is equal to 3/2 x minus -2, so it becomes x plus 2. And then put it in slope-intercept form in this case. All right, so you have y is equal to 3/2 x plus 3 plus 1. So y equals 3/2 x plus 4. Okay, so now to sketch the line, the easiest way to do it, like to sketch it on an XY, to sketch a line, there you go, there's a line. Sketch the line that passes through the point like -2, 1. Right, there it is. It doesn't have to be, such a, it depends what kind of drawing you want. Of course, they mean in the book, sketch it on a proper X and Y axis. But as my friend from graduate school always used to say, with questions of this sort, I would say, well, the teacher wants us to do this, I think. And he's like, no. He asked me for a piece of toast, and I gave him I put a piece of bread in the toaster. So sketch the line. There it is. But that's not what they mean. So the easiest way to do it is to find the x-intercept and the y-intercept, if you want to sketch it on an xy axis. Find the x-intercept and y-intercept. Well, the y-intercept is 4. Once you put it in the slope-intercept form. For the x-intercept, okay, well, the x-intercept happens on the x-axis, and on the x-axis, the y-coordinate at that point is 0, right? So set y equal to 0 and solve for x, right? That's what the x-intercept is. Right? It occurs on the x-axis precisely where the y-coordinate is 0. So you set y equal to 0, and you get 3/2 x plus 4, solve for x. So -4 is equal to 3/2 x, multiply both sides by 2/3. Multiply both sides by 2/3 to isolate the x, because the 2/3 and the 3/2 cancel each other out. So this is -8/3 is equal to x. So the y-intercept is 4, 1, 2, 3, 4, and the x-intercept is 8/3, so something, or -8/3, so something slightly less than 3. 1, 2, 3. So right about there. So there it is. All right, that's the easiest way to sketch the line. Find the x-intercept, find the y-intercept. That's just given by the slope-intercept form. For the x-intercept, just plug in y equal to 0 and solve for x. And there's a nice sketch. Okay, certainly we're going to ask you to draw a line on the exam. So 52 and 51 should be sufficient practice for that. You can pick your favorite line and sketch the graph of that one. All of that should be okay. Part B, find the equation for this line. So I don't think you can really graph it without, well, you kind of can. I think you should do part B first. Sketch the line. So first find the equation. First find the equation, then find the intercept. Another way you can do it, I think probably what they mean, is to graph that point they gave you, which was -2, -1. So, like right here. And then, slope 3/2. So that's rise over run. Rise 3, run 2. Right? So if you want to run 2, so this is -2, right? And then you get -2, +1. If you want to run 2, so this is -2 to 0, and then rise 3, then you get to 4. So, show you that. So -2, 1, and then here's the slope of 3/2. All right, this is run 2, rise 3. So you can graph one point and then graph another point by doing this rise over run hop. I don't think that's the easiest way to do it. I think the easiest way to do it is to just find the x and y intercepts. Just leave it at that. All right. So if you've ever, if you've ever done any like roofing construction, they talk about, the slope of your roof, and they'll say 3/2 or 3/1 or something like that. So for every 2 feet you run, 2 feet you run, you go 3 feet up, and that'd be a really steep roof. Certainly don't want to get on that without a harness. All right. Section 1.4. So we were talking about in section 1.4 solving quadratic equations. Remember, a quadratic equation, which is different from a quadratic polynomial. Let me just get to the problems here. All right, so a quadratic polynomial looks like this. That's a quadratic polynomial. A quadratic equation right, this isn't an equation. An equation has an equal sign in it, and it's got a left-hand expression and a right-hand expression. And there's also the quadratic formula, which is that x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, so there are these three things here. But in this section, we want to solve quadratic equations. And that's a quadratic equation in its standard form. So we had three methods, right? Three methods of solution. All right, the first method is factoring, which is the easiest if you can factor, but you can't always factor. As a matter of fact, you can hardly ever factor. Not that the problems in the book, would give you that impression. There's factoring, and then there's completing the square. And then there's the quadratic formula. Now, completing the square always works, as does the quadratic formula, but the quadratic formula is, in essence, the completing the square process was already done. So you complete the square on this equation without knowing what a, b, and c are, and then you answer you get is this. Okay. So I'm going to ask you, for sure, expect the problem to solve, quadratic by factoring, and expect a problem to solve by completing the square. Don't worry about this, although we'll do a couple examples. Okay. All right, so factoring, completing the square. I want to see you be able to do both. Okay. So the factoring is the easiest one. So which problems were there to do here? 60 to 30 every third problem. Or 6 to 60 every third problem. Where does that start? Here it is. Solve by factoring. X squared plus 5x plus 6 is equal to 0. All right, so this one factors. It's x plus 6, or x plus 3, x plus 2 equals 0. Right, so you have a product equal to 0. Within the real numbers, that means that one of the factors is 0, or the other factor is 0. Right, so this gives you x is equal to minus 3, and this gives you x equal to minus 2. So you have two possible solutions with a quadratic. Okay, so if you can factor, you know, that's the quickest, easiest way to solve. So 6, 12. So in 12, 4y squared minus 9y equals 28. This one is not in standard form. Okay, it's not in standard form yet. Okay, you need to put it in standard form to solve by factoring. Standard form means you have to have a 0 on the right. I can't do this. I can't. So this one factors like this, like y times 4y minus 9 equals 28, but that doesn't mean anything. It doesn't mean y is equal to 28 or 40, or, 4y minus 9 equals 28. That's meaningless. Okay, it doesn't mean anything. The only time you have that kind of meaning is when the product is 0. A times b equals 0 means a is 0 or b is 0. Okay? If you don't have 0 on the right, it doesn't work. So anyway, you just get the 0 on the right by subtracting 28 from both sides. Let me actually show you that so we're clear. So 4y squared minus 9y minus 28 equals 0. Now you can factor and cancel. The problem with this one, that makes the factoring a little bit more complicated is that, the coefficient of the squared variable is not 1. Now, what would make life easier would be to divide both sides of this by 4. But unfortunately, it won't make life easier because this won't be an integer anymore. So when you're factoring, if you don't have integers, it doesn't work out quite as well. But you've got something to go with here. 28. 28 is either 28 times 1, 14 times 2, or 7 times 4. For 7 and 4, I think the 9 is going to work, or would 14 and 2 work? So let's see. 7 and 4. And then this, 4y squared, right, you're going to have like 2y and 2y. All right, one of these is plus, the other one is minus. Does either of these work? So that's 14y minus 8y. That doesn't do, nor does this, right? This would be minus 14y plus 8y. That's 6y. So that doesn't do it. So the 7, 4, 2, 2 combination won't do it. You could also try 4 and 1. So this would be 16y minus 7y. Right, so 16y minus 7y. 16 minus 7 is not, that's it. Okay, right? 16 minus 7. So minus 16 plus 7. So there's unfortunately a lot of different options there. I won't give you one that's got that many options, but there it is. So this tells you that 4y plus 7 is 0, or y minus 4 equals 0. This one just means y is equal to 4. This one, 4y equals minus 7, so y equals minus 7 fourths. So minus 7 fourths and 4 are the answers to this one. Okay, so factoring and canceling is always usually the easiest, except if the factoring is really kind of, kind of dodgy here, like in this one. So we were supposed to do 6 to 60 every third problem. What about number 9? 9's a little bit easier. Let's do that one. 5x squared minus 9x minus 2. So solve by factoring. Like, again, you could divide by 5 on both sides, or multiply by 1/5. But that would give you x squared minus 9/5 x minus 2/5 equals 0. And factoring without integer coefficients is not the way to go. Okay? To do factoring with integer coefficients, you need to start with integer coefficients. Factoring with rational coefficients, that's just a disaster. Okay? You don't want to do that. All right, so you can't divide out that leading coefficient. When you're completing the square, you always divide out with that leading coefficient. Always. Okay? It makes the problem easier, not harder, even when you get fractions. Anyway, so this one's easier because 5 is a prime number, so it's got to be 5x and x, if it factors at all. Okay, it's going to factor because I told you it does. And then 2 is 2 and 1. All right, and then this is going to be 9. Well, 2 times 5 is 10. Right, 2 times 5 is 10, minus 1 is 9. So that's definitely the way to go. It's going to be the 2 here and the 1 here. It's a minus 9. So that's it. All right. This is 5x squared, so it's got to be 5x and x. This is 2, so it's got to be 2 and 1 here or 2 and 1 here. And it's negative, so one is plus and the other is minus. So not too many options there. So this tells you that 5x plus 1 is equal to 0, or x minus 2 is equal to 0. This one tells you x is equal to 2. This one tells you 5x is equal to minus 1. So x is minus 1/5. So 2 answers, minus 1/5 and 2. Factor and cancel, real easy. Okay? Real easy. Usually, unless it's a pretty dodgy factorization problem, like 12 here. But that is typically the fastest way to solve a quadratic equation. All right. But it doesn't always work. It doesn't always work because you can't always factor. So in 17 to 28, solve by completing the square. This method always works. Again, I want you guys to do a completing the square problem on the exam tomorrow. So, I'm showing you these problems, right? I'm doing these problems as examples. You need to do them too. Okay, and then you compare your answers to mine. So we're doing every third problem, so it starts with 18. So x squared plus 6x minus 2. Okay, does this one factor? This one doesn't factor, right? Because 2 is going to be 2 and 1, right? And then, plus 2 minus 1 minus 2 plus 1, whatever, isn't going to get you to 6. No way. So it doesn't factor. I mean, as you can see, things hardly ever factor. That's 2, right? That's a 2. This is x squared. All right, so this is x, 2, and 1, and then the only options you can have plus here, minus there, plus there. But that only gives you 2 possible values for this. So there's 2 possible values where x squared plus bx minus 2 factors. There's only 2 possible values for b. Right? Plus 1 and negative 1. That's it. All the other values don't factor. So as you can see, the question is, do polynomials always factor? The answer is, well, actually, hardly ever. They hardly ever factor. If you pick a polynomial at random, chances are, like 99.9% chance, it isn't going to factor. All right. Anyway, so in the book, of course, they're just picking problems that always do factor. So solve by completing the square. So with completing the square, well, you don't want the 0 on the right. You want the constant on the right. So you move that constant over to the right. So you got x squared plus 6x equals 2. Take the coefficient of x, divide by 2, and square it. Right, so 6 divided by 2 is 3, squared is 9. Add 9 to each side of the equation. You have to add 9 to both sides in order to keep the equation balanced. Right? On the left, that's a perfect square. It is x plus 3 squared. Right? X plus 3 squared. X plus 3, I'll say it in a moment. X plus 3 squared, right? I mean, if you want to multiply it out and check, x plus 3 times x plus 3 is equal to x squared plus 3x plus 3x plus 9 is equal to x squared plus 6x plus 9. There it is. All right, this completing the square business always gives you a perfect square on the left. And now you can apply the square root. So you got x plus 3 squared square root is equal to square root 11. And this is why it doesn't factor, is because the square root of 11 is not an integer. Right? I mean, how many integers are perfect squares? I mean, very few. Right? So on the left, you get, by the way, so the square root of something squared, with a variable in it, it doesn't just cancel the square out. It's the absolute value of that thing, because it could be negative. So absolute value of x plus 3, right? I mean, it's x plus 3 if it's positive. Its absolute value is x plus 3. If x plus 3 is negative, depending on what x is, like negative 7, then x plus 3 is negative, then you have to negate it to make it positive. Square roots are always positive. Anyway, to remove that absolute value, you just kind of put this plus or minus thing here, right? X plus 3 is equal to square root of 11, or the negative of the square root of 11, if its absolute value is square root of 11. Now you subtract 3 from both sides. So your solutions are x equal to minus 3 plus root 11, or x equal to minus 3 minus root 11. Right, so you have two solutions again, and the solutions include a non-perfect square in the square root, so that's why the thing didn't factor. Another example, so 18.
I have a question.
Sure.
So if your square root, like for example, you have square root 11, if that 11 was negative, would it just pretty much be no
No
solution?
solutions, no real number solutions. Yeah.
So it's just no solution?
Yeah, just no solutions once that happens.
Okay, thank you.
Mm-hmm. Good question. 21, x squared plus x minus 3/4 is 0. Plus x minus 3/4. So x squared plus x, move the 3/4 over here. Okay. Coefficient of x is 1 divided by 2. Squared is 1/4. 1/2 times 1/2 is 1/4. So you add 1/4 to both sides. This becomes a perfect square. X plus 1/2 squared is equal to 3/4 plus 1/4 is 1. Take square root of both sides. Absolute x plus 1/2 is 1. So x plus 1/2 is equal to plus or minus 1. So then subtract 1/2 from both sides. So minus 1/2 plus or minus 1. So your solutions are minus 1/2 plus 1, which is equal to 1/2, or minus 1/2 minus 1, which is equal to minus 3/2. Because your solutions are rational numbers, it means that that polynomial would actually factor. So what you could do is, like, to get rid of this 4 on the bottom here, is you can multiply both sides by 4 and then factor and solve by factoring. But no need. I mean, we did this completing the square. Completing the square always works. It always gives you the solutions, if they exist, which they don't have to. 24. I went one with 27. Let's do 27. 27. 2x squared plus 7x plus 4. Divide by 2 on both sides. Alright, so if the coefficient of x squared is not 1, that means divide out that coefficient. So this gives me x squared plus 7/2 x plus 2. Still 0 on the right. Now move the 2 over. X squared plus 7/2 x equals minus 2. Or, I mean, you could have moved the 4 over and then divide by 2. It doesn't matter. Either way is fine. 7/2 divided by 2 is 7/4. Right? 7/2 divided by 2 is 7/4. Square it, 49 over 16. So now you're going to add 49 over 16 to both sides. So now this is a perfect square. It is x plus square root 49 over 16. It's that 7/4. And it's plus 7/4 because this is plus. It would be minus if this was minus. Is equal to, over here, so this is minus 32 over 16 plus 49 over 16. So we've got x plus 7/4 squared is equal to 49 minus 32 is 17. Now take square root of both sides. So absolute x plus 7/4 is equal to plus or minus. Remember, square root distributes over division. Guys, please. Okay. Nothing distributes over addition other than multiplication. Neither squares, not square roots, not logs, not sines, not cosines, nothing. Absolutely nothing distributes over addition. Lots of things distribute over multiplication and division. Okay? So, you gotta keep those things straight. Oops, I put that in early. So now x plus 7/4 is equal to plus or minus root 17 over 4. So x is equal to minus 7/4 plus or minus root 17 over 4. So x is equal to minus 7 plus root 17 over 4, or x is equal to minus 7 minus root 17 over 4. Okay, so if the coefficient of the x squared is not 1, you just divide it out like that, and you can solve as usual. Another one, like, let's do one more example of that in the last minute here. 26, 2x, no, let's do a different one. 2x squared minus 16x plus 5. So, another example. So move the 5 over here, divide by 2 first. So x squared minus 8x plus 5/2 is equal to 0. Move the 5/2. 8 over 2 is 4, and square it, you get 16. Add 16 to both sides. This is a perfect square, x minus 4 squared. All right, square root of 16 is 4. And because this is a minus rather than a plus, it's x minus 4 squared. 32 halves minus 5 halves. 32 minus 5 is 27. Square root of both sides. Absolute x minus 4 is equal to root 27 halves. No way to really simplify that. So x minus 4 is equal to plus or minus root 27 over 2. So x is equal to 4 plus or minus root 27 over 2. So x is equal to 4 plus root 27 over 2. Or x is equal to 4 minus root 27 over 2. And those are your two answers. Okay, so completing the square, it always works. And as a matter of fact, it's just as easy as using the quadratic formula, because with the quadratic formula, you got to remember the formula, number one, then you got to plug everything in and do the simplification and all that. So, 6 of one, half a dozen of another. I think completing the square is easier. But okay, tomorrow I need to see one example of completing the square, one problem on that. Okay? All right, so I'll be in my WebEx room at 11:30. And actually, I'll be in there this afternoon as well. I'll send you an email with a link and some extra time. If you need to meet me with at some other time, we can do that too. All right, just shoot me an email. All right, guys, have a good day, and we'll see you tomorrow.